Alright, here's some properties of logarithms. Now, I had a different slide for this, but then I was looking at the textbooks and I was like, oh dang, they have a really good chart here for my students to look at. So I just took a snapshot of it, and there you go. I want to talk about them though, because they make sense, except for number 3. Number 3 doesn't make that much sense, but we'll make it make sense. This one right here totally makes sense, because if I go, let's see, log base A of 1, what would that equal? Log base A of 1, what would that equal?
Yeah.
Think about that. A is your base. What would you have to raise it to equal 1? 0. And that's what this says. If you have log base A, it doesn't matter what the base is, that's why they put an A there, of 1, that always equals 0. Why? Because A to the 0 power equals 1. The next one, this one also makes sense. This one right here. Log base A of A. Well, what would you have to raise A to get A? 1. And so this always equals 1. And that's what this says. If the base is the same as the of number, what you're taking the logarithm of, it's going to be A. Or I'm sorry, it's got to be 1. Why? Because A to the 1 equals A. And we'll get used to these. But I mean, they wouldn't hurt to look at and try to understand. This one is weird. Okay, for this one, we're using the idea of inverses. Okay, here it is. This is the most important one, I think. If you have log base A of A raised to the x, that equals x. And this is why I think it is, and I think I'm right. If they have the same bases, they cancel each other out. Check it out. This A is also a base, right? Because it has an exponent. So if you have the same bases, they cancel out.
So if it was log 5.
So check this one out. Base A raised to the log base A of x. Well, they have the same base, don't they? They cancel out. And so I'm left with x. It's weird, but it works every time. And if you can understand those simple things, then you got it. It's kind of like, when we have 5x, we say, oh, we just, put that and then that equals x. We do the inverse. They inverse each other. I'm not sure. Here, let me let that soak in for a second. Last one. The last one says log base A of x equals log base A of y. Now that simplifies. Here, let me clear everything. Check this out. This is the first time we get to use the inverse idea. If log base A of x equals log base A of y, x and y equal each other. How do I know that? Check this out. I can raise this side to the base A and raise that side to the base A so that these are exponents. You guys see that? That's kind of weird. You've never done an operation like that. You're raising it to the base A. Why? Because if they have the same base, you could cancel them out. And I'm left with x equals y.
Are you allowed to do that?
Yes, you can. It's kind of sick. Whatever you do to one side, do the other side. Those are the only rules you have to follow. So let's try these ones. Try them. Try them right now. They should be quick answers. Don't actually write down the problems. Just write 1 equals this and 2 is this, and then we'll go through it together. I'll give you guys a minute. All right. So hopefully, if you're watching this video, you paused it and then you tried it on your own. For the first one, this logarithm has what base?
5.
And this has also a base, right? Because it has an exponent. So what is that?
X.
The base 5 and base 5, right? So they cancel each other out, so this equals x.
What? Okay.
Bases, similar bases, same bases cancel each other out. That you have to think of it like that. So here, check out this next one. So I have an equation. Now when we solve equations, we do inverse operations to find our answer. You guys remember doing that? You do inverse operations to find your answer. So that's what we're going to do here. What is the inverse of log base 2? Well, you raise it to the base 2. So now these are exponents right here. They're both exponents because we're raising it to the base 2. And check out what happens. Because they have the same bases, peace out. And so what does x equal? X equals 3.
I thought you meant like...
So it's 3 like an exponent?
No, this 3 right here is inside the log. So some people think, oh, this logarithm is multiplying to the 3. No, it's not. The 3 is inside the log. And so if you want to get rid of the log, you have to raise it to the base of 2.
So when you plug it in the calculator, the parentheses is...
Yes. Yes, that's where the parentheses go. Now, plugging into calculators, there's other things you have to consider. Calculators, a lot of calculators, most calculators have a log button. If you look on your smartphone, it has a log button. That logarithm automatically has a base 10. So there's different ways to plug it in the calculators. And so, I mean, I'll help you guys with that stuff when we get to it. But let's just focus on this stuff. Now this says log base 4 of 4. What is log base 4 of 4? 1. 1. Now, you could look at it like this, because that's a property. If the base is same as the of number, then it's 1. You could look at it like this, too. Check this out. What exponent does this 4 have? It has a 1. Numbers always have an exponent. If you don't see it, then you know it's a 1. And check it out. Same bases, they cancel out. What are you left with? X equals 1. Oh, that's pretty sick. Okay, number 4, same bases, cancel out. What's my answer? Number 5. Ooh, there's a log in the exponent. It's like all gooey. Okay, here we go. Same bases, they cancel out. What am I left with?
Log 2 x.
Log base 2 of x. Don't forget the base. All right, that's how you do those.
Wait.
Okay, here you go. Now these are the same properties that you just saw. The only difference is you see a ln. This ln, you say it by saying natural log. The reason why it's backwards is because I think in the Latin language they do it backwards, kind of like well, it's backwards according to me because I speak English. But you know how Spanish, how they like to say the noun first and then they say the adjective.
Yeah.
Like they don't say, "Oh, that's a blue book." They say, "Oh, book that's blue." They always. Anyways, so this is a natural log.
Wait, is that a 1?
Logarithm natural. Okay. No, that's a L. So this is where it comes from. Log base e is something you'll never see. You'll never see a base e in a logarithm. And the reason is, here, let's just throw an X right there. The reason is because log base e is so special, he is the natural log. So these two are the same. Now, if the natural log bugs you, take it out and put log base e until you start getting really used to it. Natural log just means log base e. That's it. And all the rules, same. So let's take a look at some problems that we have to simplify for practice.
Wait. Is that...
So try these, guys. They're kind of like the other ones. You just have to simplify them. They're quick answers, things that you should be able to get right away. I mean, I know it's your first time looking at them ever, so it's not going to be really quick for you, but you can figure it out if you stare at it for a second. Okay, so here we go. Now this first one tricks people up because they're not used to seeing the natural log. Now, if that was written, like the way that we're used to seeing it already, log base e of e raised to the 5x. This means natural log. Okay, so they have the same bases, right? Peace out, peace out. What's my answer?
5x.
Yeah. Not bad, right? Not bad. Natural log just looks so pretty the way you write it. All right, now this one right here, how do I get rid of these natural logs? Raise it to the what?
3.
Base e. Because then they would have the same bases. Peace out, peace out, peace out, peace out. What's my answer?
3.
X equals 3.
3. What about 3?
Okay, now what about this one right here? Oh, this one's kind of weird. Natural log. Wait, I wrote that wrong. That's not right. This should not say it like this. It should say natural log of 1 equals x. Sorry about that. Ugh.
Isn't that in the same?
So I go raise it to the base e. No.
You don't have to, it's 0.
Yeah, you know it's 0. Because anytime you have a 1 inside, it always equals 0.
Oh.
So, like, if I translated this, no, you could raise it to the base e. If I raise it to the base e, these cancel out.
But you have to do the same to those.
Yeah, then I have to do the same. Never mind. Okay. So if I translate it, let's see, log base e of 1 equals x. This has to be a 0 in order to get 1, because this would say e raised to the x power equals 1. Base e raised to the x power equals 1. So you know that has to be 0. X equals 0. Okay.
Oh, no.
All right, now this one is tricky. I'm sorry, I had to throw it in there. What exponent does this e have?
A 1.
1.
Has a 1. Now, can I rewrite this so that it has a negative exponent and not a fraction? Yeah, you can rewrite this as this. Natural log of e raised to the negative 1. Okay, now natural log is really log base e, right? So, what's my answer?
Negative 1.
Yeah, these cancel out, and my answer is just negative 1.
5.
Alright, what's the answer to number 5?
5.
Yeah, they had the same base, so they cancel out, so it's just 5.
It doesn't matter which one.
Ooh, number 6 is tricky.
Is that a 1 or an
That's
L?
this is a 1, and this is an L.
Okay.
See, that's why I write my L's cursive.
You should use a different.
So here, look. See, natural log of 1 over 3.
It's 0.
What's natural log of 1?
0.
0 over 3 equals?
0. Yay.
Yeah, it's exciting when you know what you're doing. Okay, what is natural log of e?
1.
They cancel out, and so you're left with the 1. So it's 2 times 1,
2.
which is
2.
2. This right here, this guy says 2 times the natural log of e. And so we get 2 times 1, which is 2.